See the same link, right? Every time the same link. There won't be any change in the link. Fine. Fine. So I started this file, terminal emulator, right? Start-dfs.sh. So okay, it's already started. It's already start-dfs.sh. Start-yarn.sh. See anyone who doesn't have knowledge on HDFS?
No, I don't have any knowledge. I don't.
Even I don't have.
So, okay. So anyone who doesn't have knowledge on HDFS, right? Okay. Fine. 1 second. Control Shift T, one more terminal. Control Shift T, one more terminal opens. Say PySpark. So to understanding this PySpark and two things you need to have, right? Okay. Tomorrow at 6 p.m. 6 to 7 p.m. right? Tomorrow you can attend that HDFS. Who doesn't have knowledge on HDFS? You can attend it.
Is there any link will be shared, or in this link only you can?
I'll forward a link tomorrow before at 4 p.m. or 5 p.m. 1 hour before the class. I'll keep in your WhatsApp group. Anybody who doesn't have knowledge in HDFS can just join this HDFS.
So this is daily batch, sir.
Not daily batch. Only tomorrow. It's not a daily batch.
Monday to
Only tomorrow I can test class. Just before.
Okay, 6 to 7 p.m. Okay.
Tomorrow. Only tomorrow. Who doesn't have knowledge in HDFS? And tomorrow you can attend. And there's one more you need to understand in Spark, PySpark, yarn, YARN, how this yarn components and yarn processing. Yes. So that next Saturday before your session, somewhere like 4 p.m. to 6 p.m. Your class will be at 6:30, right? 4 to 6 yarn I'll be discussing. So these classes you can attend, right? Everyone means they need to have this knowledge about this. If who doesn't have knowledge on HDFS, tomorrow you can attend. And next Saturday, 4 p.m. to 6 p.m., I'll be discussing about yarn. You need to understand this yarn, how the processing is happening within this yarn and how your request is forwarded, right? Those. Fine. Who doesn't have knowledge? And the regular big data students, right? For them, for yarn component, I need to discuss. So you attend this 4 p.m. to 6 p.m. next Saturday, coming Saturday. And for tomorrow, HDFS. Today, just I give an introduction to this HDFS. Just before another weekend batch is running, right? Fine. Control L. So I was saying that in yesterday, I was just discussing about the Python syntaxes, right? Understood, right, everyone? So hope everyone, your software is working, right? For everyone, the software is working, right? Fine.
Yes, sir. Yeah.
Okay. And today I'll be, so already we discussed about that. Now I'll be discussing like various transformations, inbuilt transformations, right? Inbuilt transformations in PySpark. So we don't no need to write code directly. We have got inbuilt functionalities for performing these operations. All right. Okay. What are the RTD operations? RTD operations, two operations. What are the two operations?
Transformations, actions.
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 And what you need to understand, if transformations
Needs to be performed.
if transformations applied on a RTD, transformations applied on a RTD, right?
It creates a Spark object.
Resultant is also a RTD. Resultant is also a RTD. Right. If transformations applied on RTD, resultant is also a RTD, Spark object. Next, if actions applied on RTD, resultant is a local object. Resultant is a local object. What is that? Python object. Whatever you are, if you're using Scala, it will be Scala. If you are using Python, it will be Python object. Fine. Converting a Python object. Converting a Python object to Spark object. Okay. Converting a Python object to Spark object. What is it? If we parallelize a Python object, we get a Spark object. you get a Spark object, that is what? RDD. Okay. Example, right? Example. See, just show it practically. So if this is your PySpark, x equal to yes. If you are saying in the terminal PySpark means you are by default you will get this. If you are saying only Spark means Scala you will get. Scala prompt you will get. Here you got Python prompt, right? We say PySpark Python. Spark means Scala you will get. X equal to 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Right. X is what? List. X is a list. I want to convert this list. How to convert this list to RTD? Using Spark context, if I am parallelize. Using Spark context, if you parallelize, it's an inbuilt method, inbuilt functionality, right? Parallelize. Of which one? X is a list. X is a list. If you parallelize using Spark context, then RTD1 is created. With any name you can give, right? It's RTD1. RTD1 dot collect to show all that whatever present within it, right? RTD1 dot collect, yes, it shows the output. 10, 20, 30, 40, 50, right? Yes. Understood, right? A list, if you are parallelizing, you are getting an RTD. The output same, 10 to 50.
Can we create RDD in PySpark?
Yes. So I said there are three ways to create RTD. This is the third way I discussed. This is the previously when we discussed about RTDs, I said there are three ways to create RTD. Can anyone say what are the three ways to create an RTD? First is this is the third way. Second way is this. Second way is this. If filtering, transformations, anything if you're applying. First way is if you're loading a file using Spark context, then RTD gets created.
C.context.
Now, what are the various transformations? Now, check what are the various? Yeah.
So a Spark context object, where did you create it here? SC?
Say whenever you open the Spark, right? Just observe here. Scroll up, scroll up, scroll up. Here, by default, whenever the Spark is opened, you will get a Spark context will be created automatically here.
Okay,
Yeah.
so we don't.
But
is it singleton object or what?
So here, yes. So here, Spark context will be created automatically when you open it. But whenever you are writing a .py file, we need to create it separately. So whenever you're working, right, whenever you're creating a .py file, Python file, there you need to create it. But here automatically, whenever you there is Spark session available, Spark context, Spark session available as Spark, and Spark context also by default, the Spark context will be created whenever you open this Spark. Okay.
So this Spark context object is a singleton object, right? Which is by default created.
Yes, default created. Various inbuilt. Actually, in the previous version, it is used to show here Spark context available as SC. Can you see anywhere SC is there? SC dot set log level. Spark context. Somewhere you will see here. Okay, in the previously it used to show, right? Spark context available as SC. Okay. So I didn't create it automatically. I'm using it. Automatically it gets created. Various inbuilt transformations. Various inbuilt transformations. Various inbuilt transformations. First one, we have got map. This map is different with the Python map what we discussed yesterday. This is
So can you show the output again once again? I have one question, please.
let me. This is the parallels. This is the output.
No. In the console, I've seen some other input also, like a storage 0 and 0 plus 0. What is it?
So there is a concept of stages and tasks. Stage 1, stage 2, stage 3, stage 0, stage 1, stage 2. We have got narrow transformations and wide transformations. Until narrow transformations, it will be within the same stage. If any wide transformation encountered means it will change the stage to another next stage. So what is the stages? What are the tasks? What are narrow transformations, wide transformations? I'll discuss it.
Okay, thank you.
Fine. We can say yes. Now, various inbuilt transformations, map, flat map, M capital, third filter, all these are built in. Filter, union, intersection, all these are transformations. If you apply this on RTD, the result also you get it as an RTD. Subtract. Cartesian, distinct. So not only this, we have got many more key value transformations are available. Key and value pair transformations. Okay. First one, understand this map and flat map. Map used in each and every example. In every example, we use map. Everyone understood this lambda function already? Hello?
Yes.
Stress for each element transformation. Map also, stress also, each element for each element transformation. Applying operation to each element of a RTD and returns a RTD and returns a RDD. Example, squaring each element. Squaring each element of a RTD. I want to square each element of RTD. How can I do? So, for example, squaring each element of an RTD. First create an RTD. How to, R1 is an RTD, which is going to be created. If I say parallelize, of a list, sc.parallelize of 10, 20, 30, 40, 50. It's a list, Python list. This Python list, if I'm parallelizing, I'm getting a RTD R1. Now try to just observe. What is my query? Squaring each element of an RTD. In RTD, how many elements are there now? 5 elements. Check it, R1.collect. How many? R1.collect means RTD.collect. Collect is an action. R1 is an RTD. How many elements? 5 elements. How to square it?
So this output is in Python object right now, right? What we have got add
If
one
I
dot collect.
perform action on RTD, what you get? If I perform action on RTD, Spark object or
Python
Python
object.
object? Yes.
Python object, right?
If I
Python
apply-
object.
Yes. R1 dot map. On a R1, I'm applying what? What is this map? Transformation or action?
Transformation.
Transformations. You have to
Transformation.
use the lambda expressions for the
So
squaring.
transformation. So R1 dot map. Yesterday using map, each element means each element you are going to transform, right? Then
Yes.
you will be transforming 20, 30, 40, 50. Each element transformation means map. Yesterday we have seen, right? Use the lambda syntax. Lambda
Lambda y
x or okay, x. What is the list name we have taken? X. Okay, there is no list. Lambda x.
hyphen
What is that expression I need to give to square it? For example, if the element greater than 20 means x greater than 20. If I want to add 5 to each element means x plus 5. But to square it, what I should say? X into x. 10 into 10. First time x takes 10, 10 into 10. X takes 20, 20 into 20. X takes 30, 30 into 30. Each time it takes one element 10 points. The result, whatever you get from this is what? Is a transformation or action? What is that? Spark
Then
object, Python object. Will you get a Spark object or Python object?
Spark
Spark
object.
object.
Python.
RDD. We'll get RDD, right?
If you're working with PySpark, what output you are going to get, you need to know. What output, if you are applying any functionality, transformations, actions, what output you are going to get, you need to know. So what is that you are going to get if I apply map and RTD, the result? Spark object or Python object?
Spark object.
Yes, Spark object means RTD. R2 equal to, on R1, if I perform any transformations, you got R2. In R1, the result 10, 20, 30, 40, 50. In R2, 100, 400, 900, 1600, 2500 would be in R2. Yes, R2 dot collect.
Sir,
R2.
here I can I use R1 again photo assignment here instead of R2?
Yes, you can
So
use.
that it will be okay.
Okay, this is output. Squaring each element. Output. This is the first one. Okay, in the same way, right? Yes. Five, adding 5 to each element, adding 5 to each element of a RTD. Try to say for this. R1 dot collect. Try to say.
R1 dot map
R1 dot map. Yes.
lambda x colon
X colon.
x plus 5.
The result, whatever you get, stored in R2 dot collect. 15, 25, 35, 45, and 55. Flat map, M capital. Flattens the elements. Flattens the elements. Flattens the lists. All multiple collections into one collection. The multiple collections into one collection. Ten, 20, 30 is there. 40, 50, 60 is there. And 70, 80, 90 is there. 10, 20, 30, 40, 50, 60, 70, 80, 90. You got a list. Within the list, we got 3 lists. Nested list we say, right? From this, parallelize it. SC dot parallelize. SC dot parallelize of X. Store the result in Y. What is Y here?
So RDD.
Y is an RTD here. If I am parallelizing that list X, you got Y is an RTD. Now, if I apply on Y, previously I applied map. Now I want to apply flat map. Apply flat map. Yes. Apply flat map. Lambda X.
Just to read RDD, right?
Y dot flat map. Lambda Y is a RTD. On RTD, apply flat map. Lambda X gives X. That's it. Store the result in Z. Z dot correct means what is output you get? What is flat map? Flattens the lists. Flattening the list means yes. Multiple collections into one collection. What you will get? You will get only one list. In that you will see 9 elements. You will see only one list with 9 elements. Understood what do you mean by flat map, everyone? Hello? Flattens the lists into a single list. If 3 lists are there, all that into one single list.
So it's mainly for flattening the list only.
Yes.
Okay.
What is the output of the Y?
Why,
Can we see that?
why the same output like X only? Same X output only. Now see this next is filter, 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 right?
Sir, can we use directly the X? It means can we skip that Y then if we have same output then?
Hmm?
Can we skip that Y if you are saying that X Y
This,
have the
this,
same
state,
output of the
this statement,
yes, yes,
that statement you want to skip.
yes, is it possible?
What I am trying to do in that statement?
You
Oh,
are
no, we have
converting
to get the RDD object. That is why we are using
Right.
parallelize.
I'm creating an RTD there.
yes, yes, yes. So
On RTD only you can apply flat map. On X list you cannot apply flat map.
okay, got it.
See, what all this we are discussing now,
Yes, yes,
map, flat map, filter, next, all that. You can apply only this on RTDs. So first create RTD. How will you create an RTD? Parallelize it.
Right. It's correct.
You will get y. Here, y is an RTD. What is z here? What is z here?
Python object.
Everyone.
So
That
RDD.
RDD.
Yes.
Z is an RTD. Because if you perform a transformation like map or flat map, the output you will get is an RTD. Z dot collect store in W.
W is a Python object.
Python object.
Print W. What is W here?
Python object.
Why Python object here?
Because it is doing the action on it.
W is a Python object. Yes. W is in Python object as the action is performed. Is it? Because here Z is an RTD because transformation T by R means transformation. Okay, fine. Filter elements, filter next filter elements of a RTD. Based on condition and resultant is a RTD. For example, salaries are there. List of salaries 10,000, 20,000, 30,000, 40,000, 50,000. Salaries 10,000, 20, 30, 40, 50, right? 50,000. Now, map function I'll be using here. Map function and lambda function. Using map and lambda function, I want only those salaries whose salaries is about 20,000. Filter only the salaries about 20,000.
First, we need to parallelize. SC dot parallelize.
Is parallelize compulsory here?
Yes.
So
It's a Python object.
why we are parallelizing means I need to create RTD. Why to create RTD means on RTD only we can perform all these transformations. All the inbuilt transformations of Spark you can apply on Spark object RTDs.
But this Python console, we can directly utilize the Python, methods here, right? Instead of creating the RDD. Still it will work.
Python related things directly you can apply on Python objects.
Yeah.
Yesterday, what we have discussed, map function is different from this map function. Yesterday's map function can apply on directly on Python objects. Now, whatever this map function is applied on Spark object.
Yes. So whatever the Python things we can apply on the RDD, right?
On this list directly, I can apply map function instead of what we discussed.
Oh.
It results a Python object only. But on Spark object, if you want to apply, you need to convert to RTD. So I'm creating an RTD. RTD1 equal to SC dot parallelize. SC dot parallelize of SATs. SC dot parallelize of SATs. Okay, I'm a SALS is a list, parallelizing it, and RTD is created. Now RTD1 dot filter, RTD1 dot filter. Now RTD2 is going to get created. Try to say how to give that. I want only those whose salary is above 20,000.
Lambda.
Salary is greater than or equal to 30,000, you say. Lambda, yes. Lambda.
X colon X
And
greater than 30,000.
30,000, right? X greater than or equal to 30,000. Lambda x greater than or equal to 30,000. So store it in RTD2. RTD2 equal to RTD1 dot filter. Okay. RDD2 dot collector. Store this in RES. RES is what? What object?
Python object.
Python object. Print RES. A equal to, like for example, Python, Java. Filter other than Java. Filter other than Java. Parallelize, you say? Parallelize of it. So RTD1, you say? RTD2 equal to? Yes, RTD2 equal to RTD1 dot filter lambda x. How to give the condition?
X not equal to.
Not equal to Java.
Not equal to Java. Java is there. Sorry. Okay. Other than Java, right? Yes. Union combines elements of multiple RTDs. Combines elements of multiple RTDs. By default, it performs. By default, it performs unional operation. By default, it performs unional operation. Unional operation means allows duplicates. R1 equal to SC dot parallelize. SC dot parallelize of yes. 10, 20, 30, 40, 50. RTD1, RTD2. SC dot parallelize 10 to 50, 10, 20, 30, 60, 70. RES equal to R1 dot union. R1 dot union R2. R1 dot union R2. What is RES here? What is RES here?
RDD.
RES is not
RDD.
RES dot collector. RES2. What is RES2 here?
Python object.
Python object.
Print RES2.
Sir, union is means horizontal joining, na?
10, 20, 30, 40, 50. Merging both the RTDs. Both the elements of an RTD. 5 elements and plus 5 elements, 10 elements you will get. 10 plus 10, 20 you get. Including duplicates. In mathematics, what do you mean by union? Both the sets combining, right?
Including duplicates.
Yes. For example, one more example. R1 equal to SC dot parallelize. R1 S1 dot SC dot parallelize. SC dot parallelize. Employee ID, employee name, salary. Next. 1 or 2. Employee ID, employee name, salary. Close this square bracket, one more square bracket, parallelizing. Next, R2 equal to R1 dot R1 SC dot parallelize. R2 equal to SC dot parallelize. Same employee, 103, James. 103, James, 30,000. RES equal to R3 dot color R3 dot yes, RES equal to yes R1 dot union R1 dot union R2. RES equal to R1 dot union R2. R1 dot union R2 means how many elements you will see in RES? RES is an RTD. This is R1. This is R2. R3 equal to R1 dot union. You can say R3 equal to R1 dot union R2.
It will combine R1 and R2.
R3 dot collect. And say RES. RES equal to R3 dot collect. RES equal to R3 dot collect. Print RES. How many elements you see? 3 or 4. With duplicates, right? 4 elements. So if I say R1 dot count, there's one more action count, right? R2 dot count. How many? 2. R3 dot count. R3 dot count how much? R3 dot count. 4. For example, one more action. R3 dot take. Take first 2 elements only. Yes. First 2 elements only it takes. So if you perform any operation on union, the resultant also is a RTD. Here RES is a RTD. Next, what is the next one? Right. Map, flat map, filter, union. Next is intersection. Now see this 5th intersection. Intersection. What it returns? Intersection returns only the
Combined ones.
common elements. So for example, Spark students. Spark students. People learning Spark. SC dot parallelize. SC dot parallelize, right? So some list of Ajay, Rohit, Miller, Blake, James. DevOps students. SC dot parallelize. SC dot parallelize. Yes. Amar. In this way, some list of students learning Spark, list of students learning DevOps, both students. STDS. Bracket at the last. Yes. Enter. Find the students who are learning both. Find the students who are learning both. Hmm. So both learning students which are learning. Try to say Spark students. List of 100 students, Spark students are there, 100 DevOps students are there. In that, I want to see who are learning both. Spark
Intersection.
dot intersection of DevOps. Students learning both. Okay. We'll score both. Dot collect. Rohit and Ajay.
So if there is any duplicate data inside that list, right? Will it show Ajay as 2 times or it will show only one?
The list allows duplicates.
Yeah.
So 2 times it shows.
So if I want to avoid that, we need to again do the distinct, right? On top of that RDD.
Oh, you mean to say in the output you are talking?
Yeah.
In the output it will show only writer. Like that both. 2 only it shows.
So it automatically avoids that duplicacy and it will show only the 2 members, distinct members.
1 second. 1 second. You mean to say James students there. Here you mean to say here Rohit and Rohit 2 times Rohit.
Yeah.
HIT. No, check this what it gives. Rohit, Blake, James. Rohit for 2 times. Hmm. 200.
You got it.
Next. Next is what? Yes. Subtract. 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 R1 is there. R2 is there. R1 is there, R2 there. I want R3 to be created. R3 how to be created? R1 minus R2, R1 dot subtract. R1 dot subtract. R3 equal R1 dot subtract R2. What is output you get? From R1, remove R2 elements. What elements of R2 you can remove from R1? 10, 20. The output will be what? What elements of R2 you can remove from R1? 10, 20, 30, right? The output will be what? What is it? Subtract, yes. Okay. This is R1, this is R2, subtract. Subtract, there's a typo in subtract. R3 dot collect, R3 dot collect. 40, 50. R1 equal to SC dot parallelize, R2, R3 equal to R1 dot subtract R2, R3 dot collect 40, 50. Okay, next R4 you check, R4 equal to R2 minus R2 dot subtract. Mhm. R4 dot collect. This. Okay. R4 dot collect means from R2 remove elements of R1. What elements of R1 you can remove from R2 means 10, 20, 30, 10, 20, 30, 60, 70 will be the output. In the previous example, right? Example to use in the previous example, I want only those who are learning Spark. I want only the students who are learning Spark. Spark students are there, right? The Rohit is repeated. Remove that Rohit. Spark, not this. Mhm. Find only those. Who knows only Spark. Find only those who knows only Spark. Who knows both we discussed intersection. Only those who know Spark. Mm. Find only those who knows not like
We can subtract, right, to get only the Spark students.
finally those who are learning. Finally, the Spark students who are learning, these are DevOps students who are learning. Finally, those who are learning only Spark. Who are learning only Spark. What I should do? Yes. Spark only equal to, right? From Spark students dot subtract Spark students dot subtract
The student.
DevOps underscore students. Okay. Next, Cartesian. What is Cartesian? Each element of left side will merge with
Each element of right side.
Sir, in the
Cross check.
above example, why did you create it 2 times Spark a student? RDD, parallelized?
each element of left side will merge with each element of right side. So here just each element of left side For example, mm, department numbers, SC dot parallelize, SC dot parallelize of SC dot parallelize of 11, 12, 13 department numbers, salaries, $10,000, 20,000, 30,000. SC dot parallelize, okay, 11, 12, 13 salaries are there, department numbers are there. Each department number is going to merge with salary. Fine. Okay, SC dot parallelize, department numbers and salaries are given, right? Yes, department numbers and salaries. Okay. What is the error here? Parallelize. Typo here. Department numbers, salaries, parallelize, parallelize. SC dot SC dot parallelize, SC dot parallelize, 10,000, 20, 30, right. Now, result is an RTD. Department numbers dot Cartesian. Department numbers dot Cartesian of SALS. Print RES2. Print RES2.
Sir, is there any ID is available for this?
PySpark.
PySpark code, yeah.
Yeah, you can do in PyCharm, you can do in Jupyter. and spider
Okay.
also.
Is there available in the Eclipse ID?
So mostly we use Jupyter, next
Mhm.
PyCharm, next spider. These three are mostly used for it. Eclipse we won't use for it.
Okay.
Okay. Partition. Distinct. Removes the duplicates. Removes the duplicates, right? Yes.
What is the output of these Cartesians? I don't understand.
See this
So,
11. Each element, this left side, this is right side. Each 11 and 10,000 combined as well. Next 11 and 20,000 combined. Next 11 and each element of left side will combine with each element of right side. 11 with 10,000, 11 with 20,000, 11 with 30. Next 12 also with 10,000, 12 also with 20, 12 also with 30. Next 13 also will combine with each element of left side will be combined with each element of right side.
so here it will be index 0, it means like 11 or both, right? 11 and 10,000.
11 with 10,000, 11 with 20,000, one too many.
No, if I want to get the first element here, like a 0th element, what will be the result here in the 11, comma 10,000, right? In the output.
Index.
Yeah, index.
Or
0th index, so what will be the output here?
RS2 of index, right? You will get the first element.
Okay. Both will get. Okay, thank you.
Partition. Okay, distinct is next. Removes the duplicates. R1 equal to SC dot parallelize. Ten, 20, 30 are the duplicates. Or yes, the result is an RTD. On that R1, say distinct. That's it. Directly if I apply distinct. R1 dot distinct. RS is an RTD. Only distinct, right? Yes. Next, transformations.
Vijay, suppose if I want to perform more than one transformation on the same RDD object, can I do that? Like R1 dot distinct you have mentioned, right? If I wanted to sort it dot sort, can we apply that? Like in Python?
So here R1 dot distinct dot filter, you can say.
Okay.
Okay, for example, R1 dot distinct
lambda x is greater than 20. Exe dot collect.
Mm. 30, 40.
So if we perform this, I mean, within the same RDD, right, instead of creating multiple RDDs, if we perform more than one transformation, it is the better way, or if we perform it individually for debugging purpose, it will be easier. I mean, if there will be any performance issues or no performance.
Nothing. It will be better. Your code reduces. It will be good only. But understanding wise, okay, what is that output of one will be the input to the next, right? So here also you can do it, not a problem. You are applying in 3 transformations also you can apply. Applying multiple transformations. Transformations. Next is transformations on a pair RTDs. Transformation on pair RTDs, that is key comma value pairs. That is key comma value pairs. Transformations on a pair RTDs, that is key comma value pairs, right? So we have got many key comma value pairs. First one, reduce by key, reduce by key. Second is like group by key, reduce by key, B capital, K capital. Group by key, yes, B capital, K capital. Built-in functionalities. Sort by key, B capital, K capital here also. Map values, B capital. Keys, KEYS, keys. Values. Performing joins, right? Here we have got built-in functionality. For inner join, norm join. Left outer. Left outer join. Transformations on pair RTDs. Reduce by key. Reduce by key, right? Yes. Observe what is reduced by key? Sum up. Reduce by key can be applied only on key comma value pairs. Only on key comma value pairs. For example, R1 is an RDD. HC dot parallelize list of tuples 11, right? 10,000. Okay, so this key comma value pairs, yes. So 1 second. So reduce by key, you need to have a lot of discussion on this reduce by key, group by key. So these are also mostly used to means just like groupings and aggregations. Group by key, reduce by key, sort by key, right? Transformations on pair of this key comma value pairs, right? Fine. So this is what we have discussed. It is two operations, transformations, actions, all the various inbuilt transformations, and still we have got these are the various transformations. These are other transformations, inbuilt transformations. This you cannot apply on normal RTDs. You cannot apply on this normal RTDs. You can apply only on this key comma value pair. Only on key comma value pairs only. For example, how many male employees? What is the total salary given? For that, all that. What you need to gender and salary need to extract from each and every record and aggregate. All the males you group it and aggregate them. All department level salaries I want, total salary, all department wise total salaries I want. All department level group it and aggregate. All department number 12 group and aggregate. That key comma value pairs we need to extract. Department number and salaries. City wise, what is the revenue generated? City and price, city and price you need to, so we need to extract it. And this you cannot apply a normal RTDs. All this.
Vijay, suppose we have a JSON file, right?
Hmm.
And if we want to extract those keys, keys and the values and load it into a table, so we can directly connect to a JSON file and we can do that.
Yes, I'll be showing you examples, right? How to work with CSV files, JSON files.
I mean, in our company, right? Currently, we are actually using these JSON files. I mean, we are connecting to APIs and downloading the JSONs, and then connecting to CSV, and then processing using Informatica. So in future we wanted to do it via like AWS Glue basically. So you might be knowing, right? AWS Glue backend is more of like Spark, PySpark its uses. So we wanted to process that. So is it necessary for us to convert that JSON file into a CSV and do that processing, or can we directly process the JSON file and do that loading of the table?
Directly you can do it.
Okay.
Okay, fine. Okay, so this RTD is transformations on this key comma value pairs, and after this the inbuilt actions, one by one actions I'll just discuss. Later we'll go with some cases, right? Okay, later we discuss some examples, working examples, right? After once we discuss these transformations actions. Okay, so the remaining transformations and the various other actions we'll discuss in the next session. So tomorrow, if anyone who doesn't have knowledge on HDFS, right, can just, okay. Yeah, notes are now itself I'll forward, right? Anyone who doesn't have knowledge on Linux? Anyone who doesn't have knowledge on LFS, Linux comments? So you can ping me, right? I can forward you the notes of for it or notes or videos of this Linux, because everything we deal with, right? Okay, you can just ping me personally, right? Who doesn't have knowledge on Linux, so that you need to work with these commands, right? You need to have the basic Linux knowledge. Fine, you ping me. And okay, notes, 1 second.
So the session taken on 21st on Hadoop, it's not uploaded the recording yet actually. Yesterday I've also.
Yeah. Once I'll intimate them, right? Once you forward me, I just forward that message to them. The WhatsApp.
Okay.
And I also
okay, so
given
in the group only.
yes,
Okay. So
various transformations and actions. Now you can see in the chart, right? Yes, chart. In the WhatsApp group, I'm forwarding, right? And everyone.
we did not receive yet.
Or in the PySpark WhatsApp group, right? Yes.
No, we did not get yet the power.
Three files I forwarded, right? For the starting PySpark nodes, Python examples, and the various transformations and actions, right? Okay, fine. So okay, we'll continue. Yes.